Dear students, today I am going to explain about multi-valued dependency and fourth normal form. Already in the previous class we have discussed about the first normal form, second normal form, third normal form and BCNF. Now we are going to discuss about multi-valued dependency and fourth normal form. Other normal forms are defined based on the functional dependency. Now we will see the definition of fourth normal form based on multi-valued dependency. So first we will define multi-valued dependency, then using that we will define fourth normal form. So multi-valued dependency is defined as X defines Y. So we have to use double arrow over here to define the multi-valued dependency. Suppose it's a functional dependency, means X defines Y will give. Multi-valued dependency, which is called as MVD, X define multiple arrows and then Y we should give. Okay, so specified on a relation schema R where X and Y are both subsets of R, specifies the following constraint on any relation state R of R. Okay, so here we are considering relation state. Relation state means data stored in the database. Okay, if two tuples T1 and T2 exist in R such that T1 of X is equal to T2 of X, then two tuples T3 and T4 would also exist in R with the following properties. What are the properties means? So that denote to, that is, we are going to define that T3 of X is equal to T4 of X, that is equal to T1 of X is equal to T2 of X. That is T3 of Y equal to T1 of Y and T4 of Y is equal to T2 of Y. Okay. Then T3 of Z equal to T2 of Z and T4 of Z equal to T1 of Z. That is, a multi-value dependency X multiply defines Y in R is called trivial dependency, trivial multi-value dependency. What is the condition means? If Y is a subset of X and X union Y is equal to R. If we join the subset of attributes in X and Y, we should get the original relation R. Okay. That is a multi-value dependency. Okay. So this we will define with the multiple arrows. So we are going to see that now we will define the fourth normal form with the help of multi-value dependency. So a relation schema. So whatever normal form you are defining, we are taking the relation schema. A relation schema R is in fourth normal form 4NF with respect to set of dependencies. Okay, so here it includes both multi-value dependency and functional dependency. If for every non-trivial multi-value dependency X defines Y, X multiply defines Y in F plus. Okay, X is a super key for R. Okay. So for each F plus functional dependency, so there is a multi-value dependency, X multiply defines Y. So F plus already we know it is a closure. Okay, function closure. So X is a super key of R, that X should be a super key of R. So that is F plus is a complete set of all dependencies, functional and multi-valued, that will hold in every relation state R of R that satisfies F. Each and every relation state it has to satisfy the functional dependency F. Okay, F it is also called as closure of F. F plus already we know it is called as closure of F. So each and every state this has to satisfy these functional dependencies. So that you should remember that fourth normal form when you are defining, it includes all the functional dependency as well as multi-value dependency. Okay. So that it means each state R of each relation state R of small r, always we will call relation state as small r of R indicates the relation schema. That should satisfy this F plus, that is called as a function closure. Okay. So see here, we will take this example. We are having the emp relation. In that emp relation, we are having the three attributes E name, P name and D name. That is employee name, project name, and that employee is working, and dependent name. So here we will take that there is an employee called Smith. Smith is working two projects X and Y. And Smith is having Smith is having two that is dependents. Smith is having four dependents, that is name is 2 names. So this dependent name is Anna and John. So here it is having the multi-value dependency. If you take E name, employee name, it will take P name. One E name depends multiple P names. For example, Smith X, Smith Y, same thing. Okay. And if you take E name, one E name defines multiple D names. Smith John, Smith Anna. Okay. So that it is there are two multi-value dependencies. Now we are not to convert this into fourth normal form. We are going to decomposing the relation into two sub-relations. Okay, EMP is decomposed into M projects and EMP dependents. First multi-value dependency is E name and P name. That will make it as one table. E name, P name. Together now that E name and P name together it is a primary key. That is composite primary key over here. Okay, then EMP dependence. This is a D name is this E name and D name only multi-value E name multiply defines D name. So we are making E name and D name together it is a composite primary key and we are making it as a separate table. Okay, so now we will take this M projects and M dependents are in fourth normal form. There is no multi-value dependency. So the first one you will take that M table, it is having a multi-value dependencies. So then not to convert that into fourth normal form, we are decomposing the relation into two relations, M projects and M dependents. So like this, whatever relation you are having, you have to check whether the multi-value dependencies exist. Then we have to make it. And another thing you should know, all the this condition, here the condition is there, no? That is Y is a subset of A should be a subset of X as well as X union Y should be equal to R. That condition should be satisfied. And that multi-value dependencies X multiply defines Y means the compulsory X should be a primary key or super X should be a super key. Okay, that condition should be satisfied. So then here E name that should be satisfied. If it is not satisfied, then it is not in a fourth normal form. Then it will be decomposed into sub-relations to convert to satisfy the fourth normal form. Yes, clear about fourth normal form? So go through the things clearly. That's the reason I told previously itself you should clear about the different types of keys, functional dependencies, etc. Then it is easy to understand. Then next class we are going to discuss about the another important normal form, fifth normal form. That is defined based on joint dependency. Okay, we'll see in the next class. Thank you.